This lesson will teach me to set up and solve proportions within similar figures. There are three theorems in this section. The first is called the side splitter theorem. The second, the corollary to the side splitter theorem. And the third, the triangle angle bisector theorem. The side splitter theorem reads, if a line is parallel to one side of a triangle and intersects the other two sides, it divides those sides proportionally. So, in your notes, the diagram should have the parallel line indicators. I have a triangle. It says if a line is parallel to one side of a triangle and intersects the other two. So here's your line that's parallel to this bottom side. It's intersecting the other two sides. Then it says it divides the sides proportionally, meaning the length of QR over the length of RX is going to be equal to the length of QS over the length of XY. Corollary to the side splitter theorem. The idea of a corollary is that it stems from a particular theorem. So because of the side splitter theorem, we can then make the following conclusion. If three parallel lines intersect two transversals, you guys should have the parallel lines on your diagrams. So if three parallel lines intersect two different transversals, transversal, transversal, they're going through, so they're intersecting, intersecting, intersecting. They create proportional segments. Here I've labeled the segments with lowercase letters. So that means that segment A is going to be, segment AB is going to be proportional to the length of segment D over the length of segment B. And lastly, the triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Let's go through this. If a ray bisects an angle, notice I have a blue ray. The black curves are indicating that it's cutting that angle in half. So this is the angle bisector. Since we know we have an angle bisector, and the angle bisector is going through the bottom side, it's dividing it into two segments. Those two segments are proportional, so A over B, those two segments are going to be proportional to the other two sides of the triangle. Knowing what we know about proportions, they can be set up in different orders. What you're looking for when you set up a proportion is that your diagonals match. I have a couple of examples for you. I'm asking you to identify which theorem needs to be used and then to find the value of the variable. For the first one, we have a triangle. We have the angle bisector. So this is the triangle angle bisector theorem. On an assessment, I'm not going to ask you the name, but for the purpose of the notes, I want you to see which one it's matching to. So I have an angle bisector of a triangle, so it's dividing that bottom side so that it's proportional to the other two sides. So because I went from the 10 to the 18, I'm going to go from the 12 over to the x. You can go ahead and cross multiply, and you should end up with, always double check my math, x ends up with 21. If you were to check it, put your x value here. This fraction should equal that fraction if we did it correctly. Letter B talks about three campsites are shown. What is the length of site A along the river? So here's site A. So I want to know what is this length along the river. I think this is the corollary to the side splitter theorem. Because I see multiple sets of parallel lines and I see two transversals that they're cutting through. All right, so setting up a proportion. I'm going to say that x over 8, that this length over that length, is going to be proportional to 9 over 7.2. Again, cross multiply. I ended up with x equals 10. If you wanted to plug the 10 back into the proportion, that length should be the same, or that fraction should be the same as the other fraction. And letter C. We've used the triangle angle bisector theorem. We've used the corollary to the side splitter theorem. So I guess this one has to be side splitter. But let's look at why. I have a triangle, and I have a length that's going through the triangle, and it's parallel to one of the sides. Because of that, it's creating a proportion of the side lengths. So 12 over x plus 1 is going to form a proportion to 9 over x. I went from 12 down, from 9 down. So the order that you go just needs to be similar to the order that you started. Cross multiply. I give myself a little space. So if I cross multiply, I'm going to get 12x equals, remember you're distributing here, 9x plus 9. So I'm going to subtract to the other side, x equals 3. You'll know you get it right when you go to plug it in. So 3 plus 1 is 4. So 12 over 4 should equal 9 over 3. They do. So I know I did it right. Thank you so much. Please let me know if you have any questions.